Hello, welcome to my YouTube channel. My name is Petros Foray. In today's lesson, we are going to be looking at quadratic sequences. This is a very important concept of algebra. It is important for us to understand what a linear sequence is before we start looking at quadratic sequences. We have this sequence that's starting at 8 and goes to 11, 14, 17, and 20. Let's look at the difference between the terms. Between the first and the second term, we have positive 3. And for the second one, we have positive 3. So, when we are having plus 3 throughout, it simply means this sequence is linear. A linear sequence has constant difference. So, for us to find the nth term of a linear sequence, we need to multiply the constant difference by n. And when we multiply that, we get 3n. Now, we need to find out what is the zero term. What would come before 8 when we maintain this difference? So, we are going to be subtracting 8 minus 3, and then it gives us 5. So, which means we are going to add 5 to 3n to make 3n plus 5. So this is the nth term of this sequence. Okay. It is important for you to know always how to calculate this because quadratic sequences depend on this knowledge. Okay. Let's now move to this scenario. We have a sequence that is starting at -1, goes to 1, 7, 17, and 31. Let's look at the common difference between these. Between the first and the second term, the difference is positive 2. Between the second and third, we have positive 6. We are adding 6. And plus 10, plus 14. As you can see, there is something different. Let's try to find the difference between these differences and see what will happen. So the second difference for that one is plus 4. This is plus 4. Oh, it looks like it's a linear sequence. Interesting. Now, if this is a constant difference, but on the first is different, we now can conclude that this is a quadratic sequence. So a sequence is quadratic if the second differences are constant. So the first one will be different, but the second differences are going to be constant. So we call such a sequence a quadratic sequence. How do we then find an expression for the quadratic sequence? I want you to take note. Every quadratic expression is in this format: an squared plus bn plus c. This n is the letter that is represented. Remember, we are looking for the nth term, which is the general expression. So when we have n squared, it simply means it's quadratic. For the linear, we had only a situation where we had bn plus c. So the value of n, it was n to the power of 1. But when it is quadratic, it becomes n squared. So that is what makes it quadratic. All right. So in this scenario, a, b, and c are simply numbers which we need to calculate. When we can find out the value of a, b, and c, then we are done. Let's bring that sequence again. Remember, it was starting at -1, just like that. So our first differences are those. And the second one, these are our second differences. When we are having our first and second, if our second differences are constant, we can conclude that this is a quadratic sequence. What then are we supposed to do? For the second difference, which is constant, we need to divide it by 2 to get the value of a. So 4 divided by 2, it gives us 2. So a is equal to 2. So we can substitute where a is and put 2. All right. So we are now left with b and the value of c. How can we calculate that? Let's see. So for the first part, we found a. Now, to find b and c, we need to make a table of values. A table of values is going to be having our positions, which is n. So the first position, second to the fifth. Then we are going to fill in the terms of our sequence. So for the first position, we have -1, we have 1, 7, 17, and 31. We are now going to take this 2n squared and bring it down here. So 2n squared, we are going to find the value of 2n squared. We will be taking the value of n. For the first one, n is 1. So we'll put 1 and square it and multiply by 2. So 1 squared is 1, multiply by 2, we get what? 2. Now 2 squared is 4 times 2, 8. 3 squared is 9 times 2, 18. 4 squared, 16 times 2, 32. And finally, 50. All right. Then what is left for us to do is to subtract the term minus the 2n squared. So what you are having here minus the value of the 2n squared. So we can write term minus 2n squared. -1 minus 2. It's -3. And 1 minus 8. It's -7. And then we have -11, -15, and -19. So these are the differences of the two terms which we have found here. The next stage now, let's analyze this difference. As you can see, the difference is the same throughout this sequence which is formed out of these numbers. What is the difference? When we have -3, to get to -7, we are supposed to subtract 4. So our difference is what? For this purpose, the difference is -4 minus 4 throughout. Remember, if this is the same, it means this is a linear sequence. And how do we find the expression for a linear sequence? Common difference multiplied by n. And that gives us -4n. What is the next thing that we are supposed to do? We need to find our zero term. What comes before -3 to get the zero term? Since the difference is 4, we are going to add 4 so that we get back here. And so -3 minus 4. This gives us +1. So we take that +1 and put it here. So the expression for this sequence is now -4n plus 1. And guess what? This expression is what comes in this position. So our b is -4 and the value of c is 1. This is interesting. So our final expression is now going to be 2n squared minus 4n plus 1. Perfect. Please don't forget to subscribe to the channel. Take care of yourselves and have a good day.